Hi everybody, my name is Moshe Zadka. My website is cobordism.com, where you can find every way of getting in touch with me known to humankind. And today I want to talk to you about Jupyter as your incident management tool. So I want to start by Acknowledgement of Country. I live in Belmont, in the San Francisco Bay Area Peninsula, which is the ancestral homeland of the Ramaytush or Ohlone. If you're an SRE, you might think of Jupyter as a data science tool that you haven't done much with. So I want to give a quick introduction to Jupyter. Jupyter is a language agnostic console on your browser. It saves the inputs and the outputs in a JSON file, and that file can be exported to HTML, Markdown, and a host of other formats. And when Jupyter actually needs to execute something, it uses a language execution engine, what it calls a kernel, which is weird and confusing because it has nothing to do with an operating system kernel. Terminology is hard. And usually the thing it uses is some IPy kernel. That's the thing that actually runs Python, which is the example we'll be using. It can use a bunch of languages, but it has the best support and definitely started with Python. So and Python is a pretty popular language anyway for the SRE world, so we'll choose that. And it uses IPy kernel in a virtual environment to actually run whatever it is that you need to run. Okay, so now that we understand the tool, the history, as probably you have heard of, is Jupyter came from data science. So what makes it so good for data science? Scientists like to share the work with each other, but they also want to be able to modify slightly the experiments to see how things will behave if you do things a bit differently. And it's an exploratory tool, because in science you don't know the answer in advance. You have no idea even if there is an answer or what direction it lies. You need to explore in all kinds of directions. Jupyter is meant to support that. And I think it's interesting to think that these are exactly the thing that we need when we are resolving an incident. We want to be able to share work so other people can learn from our incident after we're done. We want it to be in an executable format, so if someone actually needs to rerun the same step, they can just get the notebook and run it again. And of course, when you get an incident, you have no idea what's going on. Right? When you're launching, if you already knew what's going on, this would be a very short incident, you just fix it. Usually, it can be any number of things. You don't even have your hypothesis in order, and you need to explore and figure out what is the current situation before we can actually resolve the incident. So to resolve an incident, I need an incident. And I need to resolve an incident pretty quickly because I only have so much time for the talk. So the stack will be pretty simple and the incident will be pretty straightforward. I realize that real incidents are complicated and real stacks are definitely more complicated than that, but we only have so much time. So imagine you have some vague service. It doesn't matter what it does, but your team is in charge of its SLAs. We need to make sure that it meets the criteria. And as Slack would have it, there's always a fly in the ointment. A page comes in, something is out of SLA, we need to figure out why. And this is often the case. We have no idea. We're probably sure it's a service, but it's not really obvious what's going on. What are the symptoms? The P90 latency is spiking. But the problem is that each server has a slightly different typical behavior. These are not homogeneous servers. They have different kind of workloads, which is maybe not ideal, but the world is filled with not ideal stacks that still need to be managed. And we want to be able to figure out which server is misbehaving and fix it. An incident, of course, is a detective story, right? The whole point is to figure out who done it. But this talk is not a detective story because I want to concentrate on how you use the tooling to figure out what's going on. So I'm going to give you the spoiler. One of these servers had a core file dumped, and not everything is impacted by that, but some queries that maybe scan some files and take too long to figure out that the core file is not relevant, are taking too long, and that's a problem we're going to have to resolve. I want to lay it out because it's a very simple incident, but I have very little time to resolve it. And I want you to think about that incident as we're exploring. So I will do it from my perspective and pretend I don't know the whole story yet. So I open up Prometheus, which is a popular monitoring tool. And in this case, I had 4 lines because I had a pretty simple environment. Of course, in a real environment, you had a lot of lines going on and about. And I have no idea what's going on here. What's good behavior? What's bad behavior? I suspect it may be the one that's highest, but that's not obviously true because maybe it's supposed to be high. I want to look for the thing with the biggest amplitude. And it's kind of hard to estimate amplitude with my eyes. But since I already have Jupyter open, I took a screenshot of that and I put it right in the incident by using pill. Now I have a record of what I saw. So at least like there's a reference point for where I started the incident from. That might be relevant later, and we'll talk about this. This kind of is a Chekhov's gun for later. But I want to analyze. I want to figure out which service has the biggest amplitude. Like I said, it's hard to do it with our eyes. It's probably possible to write like a really, really long Prometheus query that gets that, but that's often annoying, right? Like Prometheus is designed for straightforward, reasonably queries. Yes, it's probably Turing complete-ish, but dear God, it's not really designed as a programming language. So instead, what we're going to do is we're going to use Python inside of a Jupyter notebook to grab some of this data. And that's not hard, right? We just get a client, we figure out we want 5 minutes worth of data to have enough meat to analyze. And we do the query range. It's a very straightforward query. We want to start 5 minutes ago. We want to end now. We want every 10 seconds. Obviously, it depends on like exactly what you would need. But again, like I said, assuming that I already have some context of this server, I know that this is usually what I want. And the nice thing is that before I analyze the data, I can take a quick look at the data, see that it looks more or less okay. Of course, I'm not going to spam myself with numbers. These are a lot of numbers. If I'm going to intake a lot of numbers via my eyeballs, I'd rather have the Prometheus graph. At least it's nice and visual. But I inspect a few of the numbers, eyeballing, just to make sure that I probably got the right numbers, that it looks like I have enough samples in there, that I didn't make an obvious mistake in my query. And now that I have the data, it's pretty straightforward to write a little bit of code to analyze it. So let's figure out the amplitudes. We just grab all the values from each label, get the max, get them in, subtract them, find the maximum, and that's it. We have object 4, and object 4 has the biggest amplitude. Now we know which service is the part of the service that's misbehaving. Like I said, it's not homogeneous, so we know which instance of the service is misbehaving. But that's not enough. There's an actual host. In this case, it's going to be a VM in AWS because this is a pretty popular stack. Yes, objectively. So I want to figure out where this object 4 is, which instance is actually backing up object 4. And luckily, I have labels on my EC2. Now, of course, you can search EC2 by label, but in real life, it can get a bit more complicated. Maybe you have some criteria on the label, or some, like maybe this only gives you part of the label and you'll want to compare. So it's kind of nice to be able to, again, run some code and instead of eyeballing or try to figure out how to phrase it exactly in the way that the AWS console behaves, let's just write some code. So now that we found object 4, we need to find the instance. We use Boto3. Again, we can use it in another cell of Jupyter. Of course, we definitely don't want to put the credentials, especially the secret key, in Jupyter, because we want to be able to share that network. Sharing secrets is like bad. So that we will put in a file, and it doesn't really matter if that file is not reproducible. Presumably, anyone else who needs access to a similar environment will have their own credentials, or maybe they'll have their own way to get the same credentials, depending on exactly how your organization manages its AWS credentials. But that's fine. Like, secrets are not supposed to be reproduced. But assuming that you have the secrets, now you can connect and create an EC2 client. Now you can grab the instances, loop over them. The described instances API is probably one of the oldest in AWS. It started a long time ago with EC2. So it's kind of an awkward API. Regardless, we can grab the tags. We can check that we find a key that has kind and the value is object 4. And we know that this is the right instance. We found the instance. It's instance I something or other. And again, like, I don't really care what the instance is, but I want to have a record of it, right? That record will be relevant later on when I, maybe go to CloudWatch or do stuff like that. But again, like, I found the instance. It's I something, 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 very long number. Now it's time to actually confirm that this is actually a core file problem, and then resolve the problem. So let's do that. So I'm going to use another cell of Jupyter. I'm going to use Paramiko. Paramiko is a library that is designed to do SSH. Now, I know what you're thinking. Just type SSH from the command line. What's the big deal? So, again, like, this is a simplified incident because I only have so much time. But imagine that object 4 is made of like 4 instances, and I need to loop through and figure out which one is going to have the core file in it. It's pretty easy to add like a for loop around this, but if you have to SSH to 4 thing, it takes 4 times as well. And again, like, it scales really badly. What if tomorrow the service goes bigger and object 4 becomes 10 instances, and you need to figure out which of those 10 instances is doing badly? That's definitely not going to be fun. So it's kind of nice to be able to automate it, the SSH. So I connect, I got the private IP address, presumably I'm in the right VPN, otherwise you'd want to grab the public IP address, and in this case I connect to root. Again, this was a simplified environment that I created purely for the goals of the talk. Usually maybe it's not a great idea to SSH directly to root, but in this example it will do. And again, like, I only have so much time to show all the details here. So first we want to confirm the problem, that there is actually a core file. So we remotely run ls. There is a core file. That was a problem. So let's fix it by removing the file, right? Like, we don't really have to do anything with the core file. So we move it. And then, of course, confirm that it is gone. I added these dashes around the SED out read because otherwise it would have been empty and kind of boring and weird to see. In actual Jupyter, it would look a bit nicer. This is an export from Jupyter into a slide deck, so I wanted to make sure that it's very clear that I actually did finish the print, and I just have zero files in this folder, and the problem is gone. Usually we would continue checking on Prometheus and stuff like that, but we already saw all this stuff, so I don't want to bore you with repeating what we've done so far. But hopefully that showed you that, like, all these steps can be done directly from Jupyter. But sure, it's a nice environment, and Python is a flexible language, and it has web API to connect to Prometheus and dedicated API to connect to AWS, and Paramiko to automate the SSH, which is a lot of tools that you often need when you do operations on these kind of environments. But what did we actually get from all of this? So the incident is resolved. There's no more service degradation, but the incident is not done. Usually, if you're in an organized environment, you'd want to have a retrospective. You want to figure out what happened exactly, how we resolved it, how we detected it, and figure out what we can do better next time, because there's always something you can do better next time. Right? Sometimes people call them post-mortem, which I feel is a bit of a foreign term, and I like retrospective, which is kind of nice. And I'm not going to talk about the retrospective here, but I'm going to talk about the most important thing you do after an incident, which is prep for the retrospective. You have the most information and the best memory, almost by definition, right after the retrospective. This is a good time to take notes. Luckily, you already have most of your notes. Remember, I posted the picture directly into the Jupyter, so I already have the picture of the graphs. I put a few sample numbers into the Jupyter. As a side benefit, this gives me timestamps of exactly when this happened. So I have an idea of if I ever want to go back to Prometheus, assuming that I still kept the data, I can go back post-incident and grab more data from that time period to correlate or do whatever. So I already have most of my notes, but those are just code, right? They don't explain my thought process or the problems I had or other kind of human-like or interaction-like things. So the first thing I do is I duplicate the notebook, and then so one nice thing about Jupyter, because it's designed for science, it's designed for people to explain why they've done what they've done and what they expected and what they saw, which is also what you should probably do. So you can add cells that are not code, that are markdown, ideally simplified markdown. You don't want to get too bogged down in the details of formatting, but you can add links and you can add, lists and bold and italics where they're appropriate to note it, and you can explain what happened, right? I saw this, and especially because this incident, I already knew what I was looking. It was a very straight line. Usually you'll get, divergent. You'll try something that doesn't work. You can explain what you thought and why, what you tried, why it seemed like a good idea even though it didn't work, because this is good context to explain what you've did in the research. You can add all these notes in Markdown. And when you're done, you can export it to HTML. This means that anyone who does not have Jupyter running locally can just look at the HTML file and see what you've done, including all your notes. And you can attach both the HTML and the notebook to the incident ticket. The notebook is going to be useful because it logs what you've done in executable format. If I want to run that Prometheus query again, of course, now it's going to be different, but I already have the timestamps, so I can modify it a little bit and then run it again and analyze it some more. Maybe I want to check the amplitude over 1 minute intervals because that would, give good context for what actually happened and why it took so long to be detected or whatever it is that we need to do. So we attach both of those to the incident ticket, which ideally use some ticketing system. And again, it doesn't matter, which ticketing system you use. Most of them support attachment. You can attach those files and make sure that you have a memory of what you've done. And like I said, this is going to be really good for the retrospective. In the retrospective, you can go over this HTML, especially if you actually did research to add the notes. You actually have a lot of stuff, and you can do it incrementally. You can add all the notes now, and you can collect more data from other people, or maybe cut and paste from your team's chat. Whatever it is you need to do, and add more notes to make it a really nice retrospective document so you can present it as a retrospective and people can follow what happened. So I want to leave you with a few final thoughts. Incident resolution by nature is exploratory, just like Jupyter is designed for. It's not designed to be an auditing tool. It's not an auditing tool. Think of it as something that helps you keep the notes. Ideally, when you resolve an incident, you already keep notes of what you're doing, just so that you can, if you screw up, you can know what you've done. This just helps you keep the note. This is not an auditing tool. If you want to cheat with Jupyter, you can. This is a feature, not a bug. Sometimes cheating is useful to present your data correctly. Right? It's a presentation format, ultimately. But it does help you share knowledge, which is super critical, especially post-incidents, because next time someone else will get a similar incident. And it helps you be prepared for the retrospective, where hopefully you can figure out that this is dumping cores a lot, and maybe we should automate it, or at least, manage that problem better. So I hope this was interesting. I hope you can take that and use Jupyter in your own life with when you have an incident. And thank you very much for listening to my talk. Goodbye.